Alright, this lesson is on special right triangles. It's the last lesson in the honors class for geometry. This will be the last lesson before the test. Alright, before we jump into the lesson, let's do a real quick warm up. Do you remember how to rationalize a denominator? Pretty much what we need to remember is that you cannot leave a radical or any kind of square root or any root at all in the denominator. So the way that you get rid of it is you're going to figure out a way to get the closest square, make it a perfect square so it doesn't stay on the bottom. The easiest way in this case is if I multiply square root of 3 times square root of 3, I'm going to get the square root of 9, which is a perfect square. That's going to reduce itself to work out to be just a 3. So I won't have a square root in the bottom. But if I multiply the bottom by the square root of 3, then I have to also multiply the top by the square root of 3. 3 on the outside times square root of 3 is 3 square root of 3. And then 3 square root of 3 over just a regular 3, I can cancel, and I end up with square root of 3 as my final answer. So don't forget that what you need to do is try to rationalize denominators. We don't like to see square roots left in the denominator. Can you recall solving proportions? I like to do this by cross multiplying. So when you cross multiply, you're going to make an X across the equal sign, and you're going to multiply. So I'm going to get the square root of 2 times my X equal to 4 times 2, which is 8. Now, I need to get the X by itself. So to get the X by itself, I'm going to divide by square root of 2. And lo and behold, this time I actually end up with a square root in the denominator. I'm going to have to rationalize that answer. Square root of 2 times, and the easiest way to do it would be to multiply by another square root of 2. So if you multiply the numerator and the denominator by square root of 2, you get 8 square root of 2 over the square root of 4, which of course is just a 2. Now, the 8 on the outside and the 2 can be reduced, and the final answer is 4 square root of 2. So just a quick refresher on radicals and solving proportions. And the reason I've tried to warm up with that is because you may run into some problems where this occurs. All right, let's talk about special right triangles, and let's jump right into 45, 45, 90. The first thing I want to remember is if you have a 45-degree angle and you have another 45-degree angle, what happens is you have two equal angles. And we learned just a couple days ago, if you have two equal angles, you're going to have two equal sides. So the side across from that angle is that one. The side across from this angle is this one. So it's always the sides opposite from the angles. So that means that I'm going to actually have those sides both be the same little unit. Now the smallest and easiest unit we can usually count on is unit 1. So if I make this leg, and just to refresh, the two sides would both be called legs, and the longest side would actually always be called the hypotenuse, which you already know. So we may use those words, just a quick refresher. But if I have one unit and one unit, and if I were to do my Pythagorean theorem, I would remember a squared plus b squared equals c squared. And if I took unit 1 and squared it, plus unit 1 and squared it, and equal to c squared, I would get 1 plus 1. I'd get 2 is equal to c squared. And when I square root both sides, I get square root of 2. That's where this came from. So that tells me the simplest and easiest 45, 45, 90 special right triangle that I can ever have is a triangle that has one unit on one leg, one unit on another leg, and square root of 2 is going to be on the hypotenuse. And what happens is those always, always, always become the proportions of the sides. So it's really 1 to 1 to square root of 2. Now if you took the time to actually work out square root of 2 on your calculator, it's approximately equal to 1.41. So just to make sure that you understand, I have a 45 angle across from its length 1, another 45 angle, and across from that is length 1. Then I have a right angle, and across from that is a side length that's 1.41. So the smaller the angle, the smaller the sides across from them. The bigger the angle, the bigger the side across from it. So that holds true. Now, it's all about ratios and proportions. So here is the magic ratio that I hope that you remember from this first page. 45, 45, 90 special right triangles are always, always, always in proportion to length 1 to 1 to square root of 2. 1 to 1 to square root of 2. 1 to 1 to square root of 2. You're going to hear me talk about that a lot. Now, I want to imagine, what if I took a triangle, like I have this one here, and let's just say it started out as a small triangle, and it had 1 to 1 to square root of 2. And then let's say that I took that triangle and I made it large. Let's say I made it 5 times larger. Okay? Just trying to relate it to a new picture. When you change a triangle and you just make it larger, but you keep the same shape, the sides are still in proportion. So that means I still would have my 45, 45, okay? So if this is 45 and this is 45, in my original triangle it was 1 unit, and square root of 2 units. Apparently what I've done here is I have enlarged the triangle, and I now have a side that's 5 units long. In other words, I have made the triangle 5 times larger. Well, if I make this side 5 times larger, guess what happens to this side? Yep, it's also 5 times larger. Well, if I make this side 5 times larger and that side 5 times larger, guess what happens to that side? Yep, you guessed it. It's going to be 5 times larger. But the thing of it is it's going to be 5 times the square root of 2 times larger, which is 5 square root of 2. So I'm going to end up with a y unit, which is the longest side unit of a square root of 2. So it has a square root of 2 in it. So x is 5, y is 5, or x is 5, and the y is 5 square root of 2. Now, that tells me that if I multiply 1 to 1 times square root of 2 times any scale factors, let's just say it's times x scale factor, any number, and it could be a 3 times bigger, 4 times bigger, 5 times bigger. 1 times x is x, 1 times x is x, x times square root of 2 is x square root of 2. So this could be thought of as the new proportions for a different triangle that's not just 1 unit. Kind of like that one turned out to be 5 units, 5 units, 5 units, square root of 2. That's what happened in that one. So of course my x, my scale factor, was a 5. All right? That is a special right triangle, 45, 45, 90. Now let's talk about the special right triangles 30, 60, and 90. All right. I want to talk about a special triangle. It's got 30 angle, 60 angle, and a 90 angle. 30 is the smallest angle. It's kind of long and pointed and skinny. 60 is a bigger angle, but 90 turns out to be the biggest angle in that right triangle. Across from a 30 is a small side, the smallest side, and we're going to, for today, for our purposes, we're going to call that 1 unit long. All right? Across from the biggest triangle, there just so happens to be a relationship that across from the biggest angle is the 90, and that one is twice as big as the first one, and it's 2 units long. All right? Now, we end up with a square root of 3 over here on the third side. So we can verify that with the Pythagorean theorem. If I knew about this, and if I knew about that, I could say, well, a squared plus b squared equals c squared. A is 1, I'm going to square it. I'm looking for the b. Of course, that's what I'm trying to verify, square root of 3. And I know the c value is 2, and I'm going to square it. So I get 1 plus b squared is equal to 4. Subtract 1 from both sides, I get b squared is equal to 3. Take the square root, b is equal to square root of 3. What I've just done is I have verified that that third side, the side would be in proportion to square root of 3. That's because it has to match the Pythagorean theorem, because it is a right triangle. Okay, it is a right triangle. So let me erase that. Let's go back to the original idea. So, again, the smallest side in the triangle is across from a 30-degree angle. The biggest side in a triangle is across from the biggest angle. Those two sides, one is twice as big as the other. The third side is actually, if you put square root of 3 in your calculator, that's approximately 1.7. I think it's 1.73, but it's 1.7. So I just want you to understand, across from the smallest angle is the smallest side. Across from the biggest angle is the biggest length side. And then 60 would be kind of sort of the medium size or the middle angle, and it has the medium or middle side length in proportion. All right? So it's all about ratios and proportions. So if I summarize, 30-degree angle always had side in ratio of 1. The biggest angle, 90, is always inside of proportion 2. And the 60-degree angle is always in proportion of side with a square root of 3. Okay? Or, if you thought about it as scaling it up, making it, let's just say, 5 times bigger, and that's what I've done here. Across from my 30-degree angle is length 5. So, across from 30 degrees is normally in ratio of 1, but in my example, I have made it a 5. To go from ratio 1 to ratio 5 means I went 5 times bigger. So if I made this side 5 times bigger, guess what happens to this side? It's got to be 5 times bigger. And guess what happens to that side? It's also got to be 5 times bigger. So I'm going to multiply this times 5 and this times 5. What happens if I multiply square root of 3 times 5? Well, I get 5 square root of 3. What happens if I multiply 2 times 5? 2 times 5 is 10. All right, so notice that x could be represented as my scale factor, and my x is my scale factor. The scale factor is 5 because I'm going 5 times bigger. 5 times bigger, and again, x is my scale factor, 5. 2 times 5 becomes 10. Again, being able to reason it out and look at my proportions. So this is the medium length side because it's across from the 60. Okay, so that would be in proportion of 5 with the square root of 3 because the middle one has a square root of 3 in it. The largest angle is the right angle, and it's twice as big as the short side, and so it becomes 10, and x was 5 with radical 3. The advantage to knowing about 30, 60, 90, and 45, 45, 90 is there are right triangles. You could always do these with the Pythagorean theorem, but if you know these relationships, they always hold true. All right, so another way to look at it is, if I had my 30-degree angle, let's just say it has x length, all right? My medium side angle across from a 60 is going to be that x length times square root of 3. And then my longest side is going to also have that x length, but it's going to be doubled. It's going to be twice as long as the smallest side. All right, let's try some. Let's try some. All right. My first one right here, number 1, let's call it. Number 1, I'm looking for A and B, and on the second one, I'm going to look for C and D. Which one would this be? Is it 45, 45, 90, or is it 30, 60, 90? Well, hopefully the marks give it away. If I know these two sides are equal, then I know this angle must have been the same as that angle. And if these two have to be the same, and this one's 90, there's no question about it. That has to be 45. That has to be 45, and that one is 90. So this makes this a 45, 45, 90 right triangle. So I'm going to remember my ratios are 1 to 1 to square root of 2. Verified by the Pythagorean theorem and written on the very first page of notes. Okay, here we go. I gave us that 7 is across from a 45-degree angle. So my new value is 7. 7 is across from one of my 45-degree angles. Well, if this side is 7, this side is actually the same exact length, so guess what it is? 7. So it looks like I must have made this triangle approximately 7 times larger than the original triangle. So if this one's 1 times 7 is 7, 1 times 7 is 7, then it'd be square root of 2 times 7 is 7 square root of 2. It's like I multiply each one of these by a factor of 7. Okay, so that makes the B side 7 square root of 2. Do not want to see any decimals. I'd like to see the square root of 2's and the square root of 3's show up wherever it's appropriate. Okay, let's look at the next one. Which one do I have this time? I have the 30, 60, 90. So if this is 30, and this is 90, this has no choice but to be the 60. So first thing I'm going to think about is my proportions, 30, 60, 90. If you go back to the second slide or the first page of notes, you know that this is in proportion of 1 to square root of 3 to 2. The shortest side is half as long as the longest side, or the longest side is twice as long as the short side. The middle length side always has a square root of 3 associated with it. All right, let's see what we have. I have D across from 30, so this one is going to be my letter D. I don't know what D is right now. Across from the 90, I have what? 18. So there has to be a relationship, and it has to be the same relationship between all of these. Across from the 60 is letter C. So I'm looking for C and D, and right now I have a known relationship between the side that started out being twice as long as the first one. Now that side is 18 units long. So what did I do to get a side that's 18 units? Well, apparently I must have multiplied times 9. That means if I multiply this one times 9, guess what I need to do? Multiply them all times 9. What's 9 times the square root of 3? 9 square root of 3. You can't multiply an inside and outside number, so you just have to put them together. 1 times 9 would be what? 9. Does that hold true when we look at it? I believe so. The longest side is twice as long as the shortest side. So if this is 18, this should have been 9. And of course, the middle length side is associated with square root of 3, and it would be 9 square root of 3. Sometimes it's easier to think of it as x, x square root of 3, and 2x, where in this case my x value was, guess what? 9. Okay. X representing the scale factor. All right, we've done those 2 examples. I'm gonna pause it, let you pause it, see if you can try these few right here, and then you can come back with us. All right, we're taking a look at the first one. I believe I have it set up as 1 to 1 to square root of 2 because this is 45, 45, 90. I'm going to pause again, see if you can figure out the triangle. All right, how did that first triangle go? Were you able to reason out that we must have had a scale factor or a multiplier of 8? And again, if this side is 45, this angle must also be 45, which means that this side has to be the same length as that side. If this side is 8, this one should also be 8. And everything is multiplied by 8. All right, let's try the second one. We're looking for x and y. I'm going to pause it, or you pause it and see what you come up with. All right, were you able to reason out that 6 is across from the 30, y is across from the 60, and that x is across from the 90? All right, so you should be able to reason that out. Now, can you use your known ratios of 1 to square root of 3 to 2 to figure out what the multiplier would be and how to reason out what the values would be? How would I get x and how would I get y? Pause it. All right, did you get 6 square root of 3 and 12? Hopefully you did, because the shortest side is across from the 30, and it is 6 units. Well, there is a relationship between the shortest side and the longest side, and the longest side is always twice as big. So if this is 6, this would have to have been 12, because we are actually multiplying everything by square root of 6. And of course, 6 times the square root of 3 is square root of 3. All right, I'm going to let you pause it, or we're going to pause and we're going to see if we can figure out the bottom 2 triangles. All right, were you able to get that far on this one? Would you figure out that across from the 90 is where I have my 24? So what started out as original ratio of 1 to square root of 3 to 2, you got to sort of memorize that. So 1 to square root of 3 to 2. So across from the 2 is 24. So you kind of want to ask yourself, what happened if my original triangle was 2 and now my bigger triangle is 24? Looks like we multiplied times 12. So if I were doing this correctly, I would multiply every one of my known scale factors, or one of my known factors proportionally, times 12. So 1 times 12 would be 12. I'm thinking K should be 12. 12 times square root of 3 would make J be 12 square root of 3. And of course, 2 times 12 gave me 24, and that was what information was given. I believe that is correct. K would be 12, and this would be 12 square root of 3. This is the shortest side. It should be half as long as the longest side, and that holds true. And the middle length side is times square root of 3. All right, you can pause it, and we'll set up the next. All right, were you able to kind of reason out that across from the 7 is 45-degree angles, and so each one of 45, 45, 90 is 1 to 1 to square root of 2. And across from the 1 is like 7, so it's like we made it 7 times larger. So it looks like we multiplied times 7. Multiplied times 7, which means this would also have to be multiplied times 7, and that proportion is 7 square root of 2. So it's 7 square root of 2. All right. We're going to see if you can try a few more. See if this gets easier and easier. The first one here. I'm going to let you pause it, and we're going to come back, and I'm just going to have the answers to see how you're doing. All right. How did these go? Hopefully these were a little bit smoother. Again, look at your ratios. This was in proportion of 1 to 1 to square root of 2 because of the 45, 45, 90. So this one was 10 times the square root of 2. So it looks like we must have multiplied that one times 10. So that means everything else was multiplied times 10, and so I got 10, 10, and square root of 2. So that's where 10 and 10 came from. All right, proportion over here is 1 to square root of 3 to 2. What I was given was across from the 30, which is the smallest side, which is 7. So it looks like I multiplied that one times 7, which means everything else has to be times by 7. So I got 7 root 3 and 14. All right. I'm hoping that the proportions become something that you get more and more familiar with. All right. We're going to move on to what about these? And we're going to look closely because these sides don't match up to what we first might expect. So we've done some where the sides seemed like they just fall right into the pattern. But every triangle doesn't fall into the pattern. So I want you to know how to handle it when you see it. All right, the first one that we're going to look at here, the first one is a 45, 45, 90 right triangle. Because if one angle is 45 and this is 90, that one has to also be 45. I also know that this side is square root of 3 and this side is also square root of 3. But I'm not used to seeing square root of 3 on these sides. I believe if you go back and check 45, 45, 90, I believe the original proportions are 1 to 1 to square root of 2. I don't really have, in the past, I haven't done any square root of 3s like that. So what I'm going to do is I have to just go with what I have. So it looks like across from the 45 is the square root of 3. Across from the other 45 is also a square root of 3. So what did I multiply by? My original factor was 1. What would I have multiplied by to get square root of 3? Well, it looks like I multiplied by square root of 3. So that's just a different scale factor. So it makes the problem a little bit different, but it doesn't mean we still can't solve it. You can still use your same methods to figure it out. So if I multiplied 1 times square root of 3, and I multiply the second 1 times square root of 3, then I should also multiply square root of 2 by what? You got it, square root of 3. Square root times square root, you multiply and keep it under a square root, which would give me square root of 6. X should be the square root of 6. Not what you first expected, but it's still something we can solve. All right? Okay. How about the next one? The next one is also a 45, 45, 90 right triangle. Just for the purposes of saving a little bit of time, I'm going to reuse my original scale factor that I wrote because every 45, 45, 90 is always going to be in this ratio. So that is something you need to know, need to memorize. So across from the 45, that side, and this has to be 45 also, so this side, X and Y should be the same. So it looks like X and Y are across from the sides that are originally in proportion of 1 to 1. So if I know X, I know Y. Looks like the longest side is 20 square root of 3. Uh-oh. This is not easy to find out what the multiplier is or what the scale factor is. So this is where I'm going to introduce proportions for the first time. We used proportions when we did law of sines. So when we did law of sines, what we found out was if you have something you know, you can set it equal to something where you have an unknown. Well, it looks like I know this proportion right here. Because originally in the 45, 45, 90, the side across from the 90 should be in proportion of square root of 2. But in this triangle across from the 90 is in proportion of 20 square root of 3. So these two are related. So that's a known relationship. Now I can set this equal to either one of these, and as long as I have one that I know and one that I don't know, I can solve. And in this case, once I get one answer, I really have both answers. So I'm going to just set it up easy. I'm going to say, okay, 1 is to X, and the same way that the square root of 2 side is related to the 20 square root of 3 side. Does everybody see what I did? I just simply pulled down one proportion and one ratio I didn't know, and one that I did know. So this is kind of like why we did that a few minutes ago. So what we're going to do is we're going to cross multiply. I'm going to get the square root of 2 times X is equal to 20 times the square root of 3. How do I solve for x? Well, x is not underneath the square root, so I'm going to have to divide by that square root of 2. Remember how we rationalize the denominator? X is equal to 20 square root of 3 divided by square root of 2. Can't leave square root of 2. So I'll multiply by square root of 2 on the bottom and multiply by square root of 2 on the top. I'm going to end up with what? Well, outside times outside, inside times inside, I have a 20. And square root of 3 times square root of 2 is square root of 6. On the bottom, square root of 2 times square root of 2 is square root of 4. Okay, let's keep going. There is no way to simplify square root of 6, so that's all I have. But the square root of 4 does change into a 2. So square root of 4 is 2. I can actually resolve this. So 20 divided by 2 is 10. And the square root of 6 is there too. My x and my y both turn out to be 10 square root of 6. Not an answer that I might have originally been able to see, but definitely an answer I can find when I set up and solve a proportion. So when you come across sides that are not easily seen, please, please, please consider using a proportion. Cross multiply and work it out. All right, I want you to pause the video, and I would like you to try these next two. One's a 30, 60, 90, and one is a 45, 45, 90. The sides don't match up perfectly to what we've done before, but we should still be able to set up a proportion and solve. So I'm going to tell you to go ahead and pause, work them out, and come back and check the answers in just a second. All right, were you able to set up your 30, 60, 90 like this? All right, this is what I wanted it to be set up. I had forgotten to list my original proportions. All right, remember, this is not one that easily jumps out at me that I can easily find, but I do believe I can set up and solve for it. So I have to be able to pick a known ratio. So I know that the square root of 3 side compares to 8 in the same way. And this time I actually have 2 that I have to find. Okay, I'm going to find x. So I'm going to use this one. And I'm going to see, set it equal to 1 over x. Cross multiply. Square root of 3 times x is equal to 8. Divide by square root of 3. Okay, x is equal to, have to rationalize the denominator. So times by square root of 3 on the bottom, times by square root of 3 on the top. I'm going to get 8 square root of 3 over 3, and those won't cancel. So 8 and 3 are on the outside, but they will not simplify. So that is my answer for x. Kind of ugly and chunky, but it's the correct answer. Now, do you remember that x is being on the shortest side? This is 8 square root of 3 over 2. What's the relationship between the shortest side and the longest side? Do you remember that they're just simply doubled? So what if I multiply this times 2? What happens if you multiply this times 2? Well, it's kind of like 2 over 1. I'm just going to multiply outside times outside. I believe I get 16 square root of 3, and you still have 3 times 1 on the bottom is just 3. That would be my solution for x and for y. Not what you think, but it can work. All right. All right, did you get this one set up? Let's see what you got. Pause again. This is my known ratio, square root of 2 over 10. So the square root of 2 is related to 10 in the same way, and I'm just going to pick x. 1 is to x. Cross multiply. All right. Square root of 2 times x is equal to 10. Divide by square root of 2. I can't leave my answer like this, so I'm going to rationalize by multiply by square root of 2 top and bottom. I'm going to end up with 10 square root of 2 over 2. These are going to cancel, so I'm going to finally answer is 5 square root of 2. So this is going to be 5 square root of 2 here, and this side's also going to be 5 square root of 2. I simply called those x and y, even though I suppose I didn't have them marked. I simply used x and y. All right, we're down to the last two. Hopefully this is getting to be a little easier. This is 30, 60, 90, so if I set up 30, 60, 90, hopefully my proportions are 1 square root of 3 to 2. Hopefully that is really becoming more and more familiar to you. Look and see what you have. Across from the 60 is letter V, so this is going to be letter V. Across from the 30 is what we have with 5 square root of 3. So across from the 30 is 5 square root of 3, and then the other one is W. Now, I can do one of these pretty easy. So I'm going to do W. You remember the relationship between the short side and the long side? Isn't the long side twice as long as the first side? So this would actually be 5 square root of 3 times, square root of 3 times 2. It's 5 square root of 3 times 2. I believe that makes it 10 square root of 3. So I actually just reasoned out W because of my known answer. What that does is that actually gives me a couple of ways I can use to find V. I usually go with what I have given, so I'm going to use this one. It seems to have smaller numbers in it. 1 is related to 5 radical 3 in the same way that square root of 3 is related to V. I'm just pulling them out of my chart. So organizing information is very, very helpful. What happens this time is really nice. 1 times V is V. V is already solved for. 5 square root of 3 times square root of 3 is 5 times the square root of 9. And what is the square root of 9? Well, that comes a 3. 5 times 3, and 5 times 3 is, guess what? 15. So my V turns out to be 15. Didn't expect that, but sure enough, that's what it turns out to be. Last one of the practice problems. I appreciate you sticking with us. If this is 45, that makes this one 45. And basically, what can you tell me about the two legs across from the 45? Aren't they the same length? So if this is 6 square root of 2, I probably can reason out that this one's the same thing. So I bet it's also 6 square root of 2, which means D is the only one left to find. Okay, I'm going to resort to my 45, 45, 90 because that's my strategy. 1 to 1 to square root of 2. All right, and I know these are in proportion of 6 square root of 2 to 6 square root of 2. Oh, excuse me. And then this would be across the 90 is where letter D is located. So I have a known ratio, and then I have one that I'm trying to find. So I can set these two equal to each other. So 1 is to 6 square root of 2 in the same way that square root of 2 is to D. And what happens is cross multiply. D is equal to 6 times the square root of 2 times the square root of 2 becomes square root of 4. This becomes 6 times 2, which becomes 12. So D is 12. Hopefully that has gotten you well on your way. So when you go and do your homework exercises, some of these will be very fast and quick and easy. Some of them you may have to pause, set up a proportion, but keep working. The answers are posted on my website.